We looked at the tectonic timescale changes where the continental drift affects climate. It still happens, so continents are still moving, but only Himalayas are rising, and nothing major is expected right now. But over billion-year timescales, obviously continental drift has changed climate quite a bit. The next timescale is the orbital timescale, where the orbital parameters of the tilt with respect to the plane of the ecliptics around the sun, the point of the axis can be different. Right now it's at the North Star. It can change over some time scale because of the wobble or the so-called apsidal precession, as we will see in a minute, where the equinoxes themselves get pulled around by the gravitational pull of the other planets in the system. And the ellipticity of the orbit changes by a tiny percent, 2%, over 100,000 year time scale. It gets more elliptic and less elliptic, which actually changes the distance from the sun a little bit. That's not a major contributor, but it turns out that the ellipticity changes modulate the precession changes and produce some time scale. So here is the apsidal precession, or the precession of the ellipse, or the precession of the equinoxes. So because of the gravitational pull of Jupiter, Mars, Jupiter, Venus and Saturn and so on, the orbit itself gets pulled around this way. So if you look here, we have now the equinoxes and solstices. As you go 5,750 years into the future, we will switch the summer solstice to September 22nd unless we keep changing the calendar. And then 11,500 years from now, this is thanks to Milutin Milankovitch, who we talked about, moves to December 21 and then to March 20th. Okay, so that's the shift in the perihelion, aphelion, equinoxes and so on. Here is the angular motion of the precession. So that's the apsidal precession and the wobble that we talked about. Eccentricity changes on these very low 100,000 year time scale, and this modulates this cycle and produces these beats at multiple time scales dominated at 23,000 years, so dominated by the angular motion of the precession. Okay, that's how we get changes in the Earth's climate from orbital forcing. So looking at the precessional index going into millions of years, you have a 100,000 year cycle, a 400,000 year cycle, and of course the 23,000 year cycle being produced by precession combined with ellipticity changes, so epsilon, sine, omega. Okay. These forcings are usually tiny, but the internal feedbacks, like the melting of the glacier or the growth of the glacier, albedo changes, more energy received, more energy reflected, and so on, they create an amplification of the radiative forcing because of the climate sensitivity to changes in the radiative forcing. Okay, so there are internal feedbacks that matter. So here is evidence of ice sheet evolution from using the O18 oxygen isotope going back about 3 million years ago, 2.75 million years ago. So first ice rafting, which is the glacier chunks breaking off and floating. Right now, for example, there is a big chunk of Antarctic glacier floating north towards some Argentine islands or Brazilian island, I think. So the reconstructed time scale shows the changes in delta O18, which is showing more ice and colder temperatures when O18 gets more depleted. Or more concentrated because O16 gets locked up in glaciers, and warmer temperatures and less ice corresponds to less O18 in the ocean sediments because the deep water is now not as depleted in O18 when the glaciers melt. So the simple ideas have to add up in your head. But within that, you are getting these multiple time scales, which I had already mentioned. The 41,000 year time scale dominated till about a million year ago, and somehow it switched to these 90,000 or 100,000 year time scale of ice ages and deglacial ages. There is lots of arguments about what caused this shift, or if this is a real shift or just an artifact of not having enough samples and so on. But nonetheless, you can see visibly that there is some change in the ice age. So that is typically directly related to the orbital forcing. This is another orbital forcing, of course, coming from this end of the spectrum of changes here. We are looking at 100,000 year time scales here. We talked already a couple of times about the asymmetric feedbacks in the glacier building phase and the glacier melting phase. And here orbital forcing created the warming first, which leads, and then the glacier changes happen. Then CO2 and methane respond because of various processes like changing the air-sea exchanges, destroying the vegetation or allowing more vegetation depending on the glacier extent, more wetlands because of glacier melt, or wiping out the glaciers, wiping out the wetlands with glacier cover, and so on and so forth. But this range of about 100 ppm change in CO2 from glaciation to deglaciation is critical. Not completely understood, but there are many hypotheses which argue where this amount of change actually comes from. Includes marine photosynthesis and land carbon sequestration, etc., because of vegetation changes. We talked about the fact that now we are increasing CO2 and methane first, and then the temperature is trying to respond. So it has not responded as fast as we expect here, even though we are in a deglacial phase, because the energy is being used up to go into the ocean and to melt glaciers, etc. So that's a very quick run through orbital time scale changes, just to give you a sense of that time scale and how that gets manifested in glacial deglacial cycles or the Milankovitch cycles. Okay.